Alright, important in the service is to make sure the drive is cleaned and greased. A typical issue that can be fatal for an embroidery machine is thread wrapped around the top drive shaft. This is an example of a not yet serviced head compared to a clean head ready for reassembly. Notice the Glytmo in the slot on each of the contact faces of the clinker and the latch. The rotary hook's been taken off this one, ready for that to be serviced as per the other video. Only 7 more heads to go. Alright, we're about to do a reassembly on a single head of a JF08 embroidery machine. The FNG, that's me, and the FOG, that's Mel, stand ready to go. Alright, first piece we want to put on is the take-up lever drive. It's been cleaned in Kero. Now we want to just give it a little bit of lubrication. So, touch on the wheel, touch in the springs, inox, wiping off the excess. Okay, we also want to make sure that the cam that it runs on, which is this in here, has plenty of clean Glytmo on the running surface. So we just got the brake off on the machine and we're just fast forwarding it through its cycle by hand. A bit too far there. Doesn't need grease everywhere else, just on the actual wear surface itself. Otherwise you just got more stuff to catch dust and crap. Right, cover plate. Next goes in 2 small screws, 1, 2. Can't now, so it's out. Cover goes in. You need to have those super tiny fingers. If your fingers are too big, you can put them on the grinding stone, dress them with a light grey diamond grit to keep the nice smooth finish on the fingers. If you use a coarse grit, you'll have a bit too much cleanup to do. So definitely recommend a diamond finish, not a 46 or a 50 grit wheel. Alright, just got those started.
The purpose of that cover plate is to prevent the thread from the bulk being wrapped around the spindle in this drive area. Clearly it doesn't work.
More, we should say, staff are clever enough to bypass such simple safety mechanisms. There we go. Okay, now this is steel into aluminium, so you don't have to welly on it. Alright. So standard torque on these. Tighten it up till the head breaks off, back it off a 1/4 turn. Or being in aluminium, tighten it up till the threads pull out and back it in a 1/4 turn. Alright. Notice we have some witness marks drawn on the top. I don't know if you can quite see those there. Those are the lines that we've drawn before we pull this top off to make sure we put it back in the same spot. Bearing's good. Liberal allocation of Glytmo onto the take-up lever shaft. Making sure we've got plenty of surface contact down in the faces. This is where the idle take-up levers sit and can rattle up and down quite a bit if there's no lubrication there. And the drive, also plenty of Glycmo around the drive face there. Alright, so this is the wheel running on that cam there. In it goes against the cam, held in place, and then the screws. One, two, three, four. Loosely snug it up. Like everything with 4 bolts, you do a circular or in and out opposite sides tightening pattern so you don't over torque the plate. But again, we're steel into alley, so we really don't want to be doing too tight anyway. Okay, check the alignment. This is for our scribe lines. That's looking pretty good there. And there. And there. And there. And there. If you need to limit the torque on these, just grip closer into the hex key. Alright. Next up is our take-up levers. These have got a machined surface on the inside that runs on that bar and a machined face here. If those are badly worn, then you'll end up with lots of noise as it's running. So you want to make sure you've got Glycmo on that drive face and also on the sliding faces there. And they just slide on. Be mindful of the electricals. It's 24 volts, but it is a safety circuit, so a break in either wire and the twin pair actives will stop the power to the machine and the auxiliary light, and also activate the brake. Probably be the last one we go, where it'll actually knock the reset switch and we'll have to restart it. So we'll see how we go. Okay, we've cleaned all of this down with kerosene and blown it dry. We haven't washed the kerosene off. Kerosene does not evaporate completely immediately, but it will evaporate over time. We've then given a very light coating all over with inox, because inox does not evaporate, just to make sure there's just enough of an anti-corrosion covering on the machine. Driving the main shaft to just move the position. 1, 2, 3, 4, and we're on needle 5, so we've got 1, 2, 3, 4 to the right, and the drive is needle 5. Okay. Top end for the moment. Now we start to focus on our drive end.
A piece of cardboard you can put over there. Sure. Yeah.
Okay. So we've got a fusible link which connects the drive, which is this arm here, to the clinker and the latch. we want to put a little bit of grease captive between the two bushings on the shaft. We have a washer on each side of the fusible link. We can then lift the drive shaft, bring that onto the drive shaft there. Okay, bring it back down again. Okay, that's the first part assembled. We need to liberally apply Glypmo to this groove, which is what holds the clinker and the latch square to the front drive plate. We want to put Glypmo on the contact noses of those two latching spaces, and also up in the back onto the solenoid latch. We have a solenoid that activates and moves that out of the way, which releases the clinker and the latch. Different machines will have a different assembly in here. On the JAF there's a solid rubber ring that goes between, but on this machine, the JF class, the contact metal to metal.
This is JB.
Oh, JF, so. Then we have a cushion ring, goes on top. And then our shaft goes upwards. So what we're expecting is we run up to the top of the stroke, where it's latched on. We'll have about 1 millimeter's clearance between the hook of the latch and the needle there. When the solenoid releases, that's when the needle drive engages. So that's the difference between a jump stitch and a normal drive stitch. At the top of the stroke there should be no movement here, and that's what the cushion is doing at the top of the stroke, is just taking out the noise and the drive at the top of that stroke. Okay, from here we're going to bring our bottom foot roller in, and this is what holds the bottom of the needle assembly in place. The whole needle assembly slides left and right for colour changes. I've got witness marks on there to say which way up that's meant to be from before. And then this is just attached with a couple of Allen bolts on the bottom. Okay, it's an M3 Allen bolt, 3mm Allen key rather. Just lightly snug it up, and then use a second M3 to set the spacing between the roller and the front tang. Again, you're into aluminium, so no need to do it up super tight. That clearance set. Okay, so we now have a cover plate. A little bit of lubrication. Cover plate allows the needle plate to go up and down, needle drive, whatever the label is. It also stops the needle from rotating on the downward stroke, because the shaft at the back of the needle bar is kept in a vertical alignment. perpendicular to the drive shaft. Again, just lightly snug it up. There is an adjustment with these two bolts on the position of the solenoid latch, which allows you to adjust the clearance of that drive nose if it needs to be tightened or loosened. You want the shaft to be horizontal, but you want it to be able to go up and down to such a point as it is firmly holding that nose. You should be able to push on it to release it with reasonable force. Okay. And back to latch position. Alright. Now, about 64 degrees, which is the vertical position. Next, we want to put some Glycmo along the bar here. This is where the colour change operation occurs. So we just have a little lubrication behind that. Lubrication on both sides of the nose there, and all along that bar. Okay. So now we have our drive ahead. This is how the needle is driven, by that nose. There's a set of felts on the top and also a set of felts underneath. And that's important to keep lubricated so that your needle bars don't wear. Two squirts on the top. This is just about out. And just one squirt on the bottom. Obviously, if you put lots of oil in these locations, they will end up dropping down the needle and onto the garment you're sewing, which is not what you want. After that's cleaned, all your needle bars should easily fall and rise. Quick wipe over for any excess. Good. Touch of Glycmo just on either side of this nose here. That runs on this machined bar, ground bar. So a tiny bit just on there as well. See the witness marks at each point of the colour change operation. Now, the secret to this is we want all our needle take-up levers up. Bit of cleaning to go there, sorry. We use one of these to just hold all the needles in a firm upright position. Bring it over the take-up levers. You can see in the back where the take-up levers are in place. You can see down this gap here where the nose of the drive is. So we want to drop the needles down slightly. You want to keep it parallel so that the other noses fall onto this support layer. And at the point where it all just wants to go in, it drops into place. There's a disc here and there's two adjustable screws here. You don't want to loosen those because that's what sets the location left and right, the angle of the needle plate, and also the horizontal position. So the needle is always coming down dead center at the fixed height from this shaft. Okay, lovely. Two more bolts, 1, 2. Just loosely, and then just recheck that you're hard down and right on those 3 stops, and just snug it up. Check all the needles are free to flow. Lovely, job done. Yep. Alright, so this is putting the final covers back onto the machine. Couple of Phillips heads at the top. As you're placing these, you just want to check left to right as well to make sure there's clearance either side of the take-up levers to avoid excess noise. These vary slightly from machine to machine. Essentially there's 6 small Phillips head screws and an assortment of pleats and wipers and thread guides. Standard maintenance procedure on a machine is that each needle bar should get a squirt of oil at the beginning of a shift or at the beginning of a week, depending on how often you want your machine lubricated. Although this machine's probably had fairly sporadic lubrication, it's still in fairly good condition, so that's part of the joy of having a nice quality machine. Okay, and then the thread take up at the top. Just another couple of screws. Typically with those we just loosely attach and then lift and lower on each of the threads so it feels like we're about halfway in the hole, just so that the bolt is attaching without it sitting on any of the threads. Job done. On to the next head.